Hello friends, welcome to Maths Nerd.
Today we will learn factorization of polynomials. So, factorization of a polynomial is a process through which a polynomial is factored into two or more factors. There are various methods for factoring polynomials. So today we will learn factorization using identities. So we will use the reverse of some identities to factorize the polynomials. The identities can be a plus b whole squared is equal to a squared plus 2ab plus b squared, and we will use the reverse of it. A minus b whole squared equals a squared minus 2ab plus b squared. We'll again use the reverse of it. And a plus b times a minus b equals a squared minus b squared, and we'll use the reverse of it. Let's see how. So we have to factorize 9x squared plus 42xy plus 49y squared. So our first job is to see whether any of these terms is a square of a certain number or a certain term, I should say. So 9x squared is certainly the square of 3x, and 49y squared is obviously the square of 7y. While if you can observe, 3x into 7y into 2 is 42xy, just like this. So now let's for a second assume that a is equal to 3x and b is equal to 7y. This is a mere assumption. So we will substitute the values of a and b in the equation, a here and b here and here. So we will get it as a squared plus 2ab plus b squared. But we have already seen that a squared plus 2ab plus b squared is nothing but a plus b whole squared. So a plus b whole squared. Now we'll replace the values of 3x and 7y. So we will get 3x plus 7y whole squared, and this is our answer. Now you will notice that I had told that factorization means factoring a polynomial into two or more factors, but here only one factor is visible. It is not so, because 3x plus 7y whole squared is 3x plus 7y multiplied by 3x plus 7y. Let's see one more problem. P squared q squared minus 4pq cube plus 4q squared. Now again we'll do the same thing. We'll see whether any of these are squares of certain terms. So p squared q squared is the square of pq, and 4q raised to 4 is this square of 2q squared. And when we multiply pq into 2q squared into 2, then we'll get 4pq cubed. So this expression here can be summarized like this. Again, for a second, we'll assume that a equals pq and b equals 2q squared. So we'll substitute a here and b here and here. So we will get a squared minus 2ab plus b squared. And we have seen that a squared minus 2ab plus b squared is a minus b whole squared. So we'll just write a minus b whole squared like this, and then we'll again substitute the values of pq and 2q squared. So we will get pq minus 2q squared whole squared. And we could factorize this into even more factors, but since we are learning factorization only using identities, we will stop here. Now we have to factorize 81p squared minus 121. Here you will observe that there are only two terms and both are squares. 81p squared is the square of 9p and 121 is the square of 11. So it is 9p whole squared minus 11 whole squared. So since we'll follow the same steps that we have used before, we'll replace 9p with a and 11 with b like this. So we will get a squared minus b squared. We have already seen that a squared minus b squared is nothing but a plus b into a minus b. So we will get like this, and then when we'll replace the values, we'll get 9p plus 11 multiplied by 9p minus 11. Now let's see a problem which is more complex than the ones we have discussed. We have to factorize 81s raised to 4 minus 72s squared t squared plus 16t raised to 4. So again we'll see whether any of these is a square of any term. So 81s raised to 4 certainly is the square of 9s squared, and 16t raised to 4 is the square of 4t squared, and 72s squared t squared is 4t squared into 9s squared into 2. So we have got our equation like this. Now again we'll use the values of a and b instead of 9s squared and 4t squared. Like this, we'll replace a here and here and b here and here. So it is a squared minus 2ab plus b squared, and that is of course a minus b whole squared. So now again we'll use 9s squared minus 4t squared because they are the values of a and b. Now this looks our final answer, but it isn't. Let's see how we can factorize it into more terms, or I should say more factors. So 9s squared minus 4t squared whole squared. Now we can see that here 9s squared is the square of 3s and 4t squared is the square of 2t, like this. And then we can forget the previous values of a and b, completely forget them because it is unrelated, and then we'll write the values of a and b as 3s and 2t, like this. So we'll replace a here and b here, so we'll get a squared minus b squared, and whole squared is always outside the bracket, but we'll focus inside the bracket. So a squared minus b squared is nothing but a plus b into a minus b. So a plus b is 3s plus 2t, and a minus b is 3s minus 2t. So 3s plus 2t into 3s minus 2t, and that is all whole squared. So it is 3s plus 2t, 3s plus 2t because it is squared and we want to remove that thing, and it is 3s minus 2t into 3s minus 2t. So in all it is 3s plus 2t squared, 3s minus 2t squared, and this is our final answer.
Feel free to ask your doubts in the comments. Thank you for watching this video. Please like and share this video, and don't forget to subscribe my channel for more videos.